Okay, today guys we're going to talk about properties of logs, and what I mean by that is ways to manipulate logs to help us out in solving equations. And so we're not really going to focus on the graphs, we're going to focus on algebraic manipulations. The first thing that I want to talk about is the change of base formula, and that is helpful because your calculator, if you notice, if you push the log button, it's always base 10. And so not everything is a log base 10. So our change of base formula gives us a way to type this in if the base is some number other than 10 on a regular log. And so what it says is if we have this situation, that is equal to the log of m with a base 10, understood, over the log of b with a base 10, understood. Okay? And so that allows us to be able to type this in our calculator. And interestingly enough, this can also be the same thing as natural log m over the natural log of b. So if you forget and you use natural log, it's not going to hurt anything. Some of our calculators now have an option that will do this for us, but you have to know where to find it. If you will hit the math button and scroll down to A, you'll see a log option, log base option, and if you hit that, you can type in something that looks like this and get the answer without having to use the change of base formula. Not everybody's calculator is that way, and they expect you to recognize the change of base formula, so there is value into learning the change of base formula. So an example that we might do would be, let's say if we want to do log base 4 of 25. Let's do 25. Because obviously you don't know 4 to what power is 25. 4 to the first power is 4, 4 squared is 16, and so on, but it's never going to be exactly 25 if we're using whole number powers. So you can turn it into the change of base formula and say log of 25 over log of 4, and type that in your calculator. You should get 2.32. If you want to try out those natural logs, type in natural log 25 over natural log 4, and you'll still get 2.32. Or if you want to try the math option, go on your math key and scroll down to A and use your log option, you can get that same answer. So another example, log base 2 of 12, you have log of 12 over log of 2, and again try one of those 3 ways or a couple of those, plug it in, your answer should be 3.58. Now we're going to talk about what is commonly referred to as the properties. These are the main ways that we manipulate logs to solve problems. The first property is about multiplication. And if you remember when you were learning to multiply the bases, you would add the exponents. And since the answer to a log is an exponent, you can add these logs. So we start out with a multiplication of x and y over here, but you can expand it and separate it. Both of them would have a base b, but you could separate it as the log base b of x plus the log base b of y. So that is multiplication expanding to addition. You can also go backwards. If you have something that looks like this, you can write it like this, which we do occasionally when we're solving equations. So that's helpful to know. The second property is very similar. It has to do with division. We're dividing two things over here, and if you remember when you had something like x cubed over x squared, you subtracted the exponents. And again, since the answer to a log is an exponent, we can subtract when we expand. So we start with x over y here, and it comes out as log base b of x minus log base b of y on this side. Again, you can go backwards. You could have something like this and want to go back to a division. That would be something useful in solving an equation. Our third property has to do with powers. And here we start out with log base b of x to some power, some number power, and we can actually take that and move it to the front because, again, the answer to a log is an exponent. We already have an exponent, so I can move it to the front and do this exponent times what I would view as an exponent here. So most people just think about taking this exponent and moving it to the front. That's what you're doing. And occasionally, like I said, it helps if you want to take that and go backwards from this situation to this situation. It depends on what we're doing. We will use this rule several times next year in calculus, so it's one to keep in your memory. Okay, so we're going to get into some more examples with this. And our first set of directions says to write in terms of natural log 2 and natural log 3. So we want to think about these numbers and how they compare to 2 and 3, and then use the properties that I just discussed to write them in terms of that. So the first thing is this natural log of 6. Well, I can immediately see that 6 is 2 times 3. So I want to think of this as the natural log of 2 times 3. And that goes back to the rule that says I can expand using addition. So I have the natural log of 2 plus the natural log of 3. Now, in the examples I gave before where we're just talking about the rules, everything I used was a log base b. Remember that natural log is a log just with base e. So everything that I said before for regular logs also works for natural logs, and that's why I'm using it now. All right, example 4, we have 2 over 27. Well, we've already got the 2. You have to think about the 27 in terms of 3 because it's related to 3. And so in my mind, I am saying, okay, that is 2 over 3 cubed because 3 cubed is 27. This will actually use two of the rules. We have a division, so we're going to use subtraction, but we also have an exponent, and so I'll be able to move that to the front. It only applies to the 3, so I'll only move it in front of the 3. So I'm going to start with the 2 since it's on top and do the natural log of 2. Then I'm going to minus what I'm doing on the bottom, and I'm going to move that power to the front and do the natural log of 3 there. Okay, I have two more examples of this same type if you need them. If not, you can fast forward. Here I have directions of write this in terms of natural log 2 and natural log 5. So when you look at the natural log of 10, you want to think of how is 10 related to 2 and 5, and it is 2 times 5. Once you write it like that, you can see that it's a product, and therefore I can expand it using addition. So I'm going to write it as the natural log of 2 plus the natural log of 5. In the bottom example, it's similar to number 4 that we did. We have 5 and 25. Now, you're thinking, okay, what about the 2? 2 doesn't fit into here. You don't have to use both of these. You just need to use those and only those. So only 2's and 5's. If you need 2 or 5 by itself, that's okay as well. So here I would rewrite as the natural log of 5 over 5 squared. When I expand this, again, division is going to expand with a minus between it, and a power is going to move to the front. So I'm going to have the natural log of 5 minus 2 natural log of 5. Okay, and in that case, you could actually look at this and say, all right, I've got 1 natural log of 5 minus 2 natural log of 5's. That would be a negative natural log of 5. You could take it one step further. We're definitely looking for this step, but if you see this, go ahead and write it. It's a good habit. Okay, now we're moving to the most common type of problem that people remember from this, and you'll see these several different places. Again, this is something we will use in calculus. And it just simply says expand, and that means that you're going to take this and look at all the ways that we can use those properties. In this case, I have several things multiplied, so I'll be using addition. And I do have the x to a power, so for the x piece, I will move that power to the front of it. They're all base 4. You want to make sure to include that. So when I expand, I'm going to start with the 5. Some people forget the number. It's by itself, okay, when you expand because it's being multiplied. So it gets its own log. So I'm going to say log base 4 of 5 plus, and then I'm going to look at the x. The x is the 1 to the power, so I'm going to make sure to put that 3 in front and do log base 4 of x. And then I'm multiplying again by y, so plus log base 4 of y. And again, the x gets the 3 in front because it has the 3 power. The y and the 5 did not have powers, so they don't have anything in front of them other than an understood 1. Alright, on number 8, I have a division. It was a little harder for me to type. So this is the top, this is the bottom. Everything's log base 2. So let's start with the top. If you just had 6x squared, it would be similar to what we did up here. So let's go ahead and write that. Log base 2 of 6 plus, because this exponent is here, I'm going to move it to the front, 2 log base 2 of x. Then you're dividing by y to the 7th and z. This is the first time we've had two things on the bottom. If it's on the bottom, it gets a minus. That's what's happening when we divide by it. So those get subtracted. The y gets a 7 in front. So you'll say minus 7 log base 2 of y and minus log base 2 of z. And again, the z does not get the 7 because that is only applying to the y. Okay, for our next example, I want to use a natural log. Again, the same rules apply to natural log and log as far as the expansion and condensing of what's going on. Alright, here you're like, this is weird looking. It has a square root. Well, what I would like you to remember is that the square root is the 1/2 power. So I would rewrite this problem as natural log of 3x minus 5 to the 1/2 power over 7. Now, that 1/2 power means I can move it to the front. A big mistake that people make is because there's a minus in here, they want to expand that with a minus, but if you remember, it takes being divided to get a minus over here. You have to keep this all together because of that minus. This is one big chunk, and we don't have rules for expansion of addition and subtraction. So that top part stays together, the 1/2 moves to the front. So 1/2 natural log 3x minus 5. Can't separate anything there. The minus ruins all of our plans. The 7 is on the bottom, and so I can subtract from there and say minus the natural log of 7. It did not fall under the square root, so it does not get a 1/2 in front. It's just plain. Okay, our last type of problem today is condensing, which is going backwards from what we just did. And so I look at whether we're being added or subtracted and what powers might be in the front. So for the first one, I'm adding, so that's going to go back as multiplication. And so I'm going to do log, I'm doing x and the x plus 1 multiplied. But the x is going to have a 1/2 power because of this, and the x plus 1 is going to have a 3 power because of this 3. So I'm going to have x to the 1/2 times x plus 1 to the 3rd. And it is the log of that whole thing, so if it bothers you that it looks kind of broken apart, you can put a parentheses around the whole thing, but you don't have to. If you're in a problem and you're solving, you need to understand it's the log of the whole thing. Alright, moving to the next one, we have a minus, and that means that we're going to go back as division or a fraction, and this one is in natural logs. So the first piece, x plus 2, and then there's a 2 power, that goes in front, what was in front goes on the exponent, and because this is in front and it doesn't have a negative, it means it's on top of the fraction. So I have x plus 2 squared on top. And then since we're subtracting natural log of x, you get an x on the bottom. For the last example, we have this 1/3 out here, and there's a couple of different ways to handle it, but let's just look at the inside for a second. And on the inside, you have log base 2 of x plus log base 2 of x minus 4. And because of this plus, that means we're going to be multiplying. So if you want to think of that for a second as bringing over the 1/3 and doing log base 2 of x times x minus 4. That 1/3 is applying to that whole thing. So you have two options. The first option is to move it up as an exponent on that whole thing. So you have to put it in parentheses, the x times x minus 4, or multiply it out and get a polynomial. And put that to the 1/3 power. The other option is know that it applies to both things. So you could put log base 2 of x to the 1/3 and x minus 4 to the 1/3. It's really just whichever one you like, or whichever one suits the problem that you're doing the best when you're actually using it in a problem. Okay, see me for your homework assignment.